Hello students, welcome to aimstoday online classes. This is a chemistry session. Here we are discussing about the chapter atoms and molecules. In this session we are going to see about Dalton's atomic theory. Before that, let us see why all the chemical laws are valid in terms of chemical reactions. What are chemical laws we have seen? In the earlier session we have seen some chemical laws like a law of conservation of mass which was proposed by Anthony Lavoisier. One more law of constant proportions or law of definite proportions, which was proposed by Joseph Proust. What does they intimate us? What are the information given us? In law of conservation of mass, we have seen that it is stated that matter neither be created nor be destroyed. In a chemical reaction, mass of the total reactants will be equal to mass of the total products formed. Just matter is changing from one form to another form in a chemical reaction, but it is not created nor destroyed in that reaction. This was explained in law of conservation of mass. And next one, law of definite proportions, which was proposed by Joseph Proust, explains that in a chemical substance, elements are always combined in the fixed ratio of simple whole numbers. From wherever you collect that sample of that substance and however you prepare that substance, the elements that always combine in simple whole number ratios to form that compound. So this is a law of constant proportions or law of definite proportions. These were proposed earlier, but here one doubt arises, that is how these chemical laws are being valid, how always all these chemical substances are following these chemical laws. By early 19th century, the scientists knew some laws governing chemical reactions like a law of conservation of mass and law of definite proportions. Why are these laws are valid? This is a question raised then. Why couldn't the elements combine in any arbitrary proportions? Why always elements are combining the fixed proportions only? Why not in different proportions? This is a question aroused then. Many scientists try to give appropriate explanations for this. So, why always elements are following these? Why always elements are combining in the fixed ratios only? Why they are not combining in different ratios? So, for this, scientists they have tried to give different explanations. Out of them, one of those is the English school teacher John Dalton. He proposed the basic theory about the nature of the matter to explain these answers. Why elements are or why chemical substances are following these chemical laws, why these chemical laws are being valid in all types of chemical reactions. For this, John Dalton tried to give explanations by proposing a theory called Dalton's atomic theory. So Dalton is not only giving the proposals, he has given some reasons for these proposals, how these are being valid by the all chemical substances. One of them is if mass was to be conserved, he assumed that all elements must be made up of extremely small particles called atoms. So, in one of the chemical laws, that is law of conservation of mass, it was proposed that mass neither be created nor be destroyed in a chemical reaction. Just it is changing from one form to another form in the chemical reactions. So, to be hold good, to mass or mass is to be conserved. So then he assumed that every element or all the elements must be made up of very small or extremely small particles called atoms. And the second law of that is called law of constant proportions or law of definite proportions. To explain this, he proposed that the particles of same substance cannot be different. That means atoms of an element or the particles or the smallest particles of a substance will be all similar one to another. Particles of a substance are same in all properties, That is why only is always they combine in the fixed ratios with other elements to form different compounds. So why they are following law of constant proportions means every substance will be having its smallest particles all similar. Particles of a substance are being all similar one to another. That is why they participate in the same manner in chemical reactions in fixed ratios. So in this way, he has given different explanations for those laws. For the law of conservation of mass, he told that atoms, there might be smallest particles for every matter which was called as atoms. Because of these atoms, mass is being conserved in the chemical reactions. And the second theory, that is law of definite proportions, is given explanation in this way. Every substance is having particles of same kind. That is why these will participate in the fixed ratios in the formation of compounds. In this way, he has given explanations and reasons for those laws. So based on these laws, Dalton proposed a new system of chemical philosophy which we are calling as Dalton's atomic theory. Let us see about that now. So postulates of Dalton's atomic theory. Matter consists of indivisible particles called atoms. So every matter is made up of very small and indivisible particles called atoms. For example, if you say any matter will be made up of small particles or indivisible particles called atoms. If you take any matter, if you break into small piece and if you continue breaking into small pieces at certain time, after certain time, we are going to get a smallest particle which cannot be divided further into simpler particles by physical means. Such particle is called atom of the substance. If you take here pencil, it's lead. Pencil lead is made up of a particle substance called graphite. So if you break into small piece, it becomes simpler. And if we continue breaking into smaller pieces, we get a very fine particle of that pencil lead, which we cannot further break down into simpler. That smallest particle is called atom. They are very tiny particles. So every matter like this is made up of tiny particles called atoms. See here, these clouds are made up of atoms. So these atoms are combining together to form group of atoms called molecules. These molecules will combine together to form one drop of water. These so many drops of water all together form a matter called here clouds. Not only clouds, water, ice, these all are made up of the small particles of water. So these water particles are made up of these atoms. So atoms are the smallest and building blocks of every matter. Okay. This is one point proposal given in the Dalton's atomic theory. Next one, atoms are neither be created nor be destroyed in a chemical reaction. Yes, atoms are not being created or not being destroyed in the chemical reactions. Just it is happening there, reorganization of atoms. Reorganization of atoms occur in chemical reactions. What does it mean? Reorganization means rearrangement of atoms is happening. Initially, in the chemical substances which are participating in the reaction called reactants, atoms are in the different proportions, in different combinations of molecules. So when they participate in the chemical reactions, these atoms will be separated and they recombine to form new substances. That will say reorganization, recombination, or we can say simply rearrangement of atoms occur in the chemical reactions to form new substances. But no destroying or no creation of atoms is happening. Atoms neither be created nor be destroyed. See here, one example is given chemical reaction. In this reaction, it is called methane. Anyhow, its formula is given CH4. It combining with oxygen to form two different substances called carbon dioxide and water. Now what is happening here? Simply burning of methane is occurring to form carbon dioxide and water vapor. In this reaction, if we observe, methane initially it is made up of one carbon atom and four hydrogen atoms. Molecular formula also shown here. One carbon combined with four hydrogens. If you see oxygen gas, two atoms of oxygen are combined to form one molecule of oxygen. So when these two are combined in the chemical reaction, rearrangement of atoms is occurring. This carbon combined with this oxygen, it is removed from these hydrogens and it is separated from hydrogens and combined with one or two oxygen atoms, forming carbon dioxide. Reorganization of atoms is happening. In the same way, two hydrogen atoms separated from here and combined with one oxygen to form one water molecule. In this way, rearrangement of atoms is occurring and new molecules or new substances are formed. That is nothing but a chemical reaction. But if you observe here, no destroying or no formation of new atoms is occurring. Only rearrangement of atoms is occurring in the chemical reaction. Thus, we can conclude here atoms neither be created nor be destroyed. All the atoms of a same element have identical mass and identical chemical properties. Yes, if we consider any atom, any element, if we collect the atoms of that element from different samples, they will be all same in all respects. Their properties will be same. Suppose here oxygen is given. If we collect the atoms of oxygen from different sources, from the atmosphere and from the laboratory prepared, from however you collect the oxygen samples, in that if you observe the atoms of that oxygen, all will be same in all properties like mass and chemical properties. These all will be same. If you see in case of nitrogen also, if you collect the atoms of nitrogen from different sources, they also will be same in all properties. Thus, atoms of an element are same in all properties. And it is extended like this here. Atoms of different elements have different masses and different chemical properties. That means if you see the atoms of different elements, they will be having entirely different properties. They won't be same in any property. For example, we told here atoms of oxygen are same in all properties. Atoms of all atoms of nitrogen are same in all properties. If you compare these two, oxygen atom and nitrogen atom, they won't have any similarities. Atoms of different elements are different in all respects. Okay, different physical properties they will be having, and even chemical properties also will be different for these. Atoms of same element are having same properties, and atoms of different elements are having different properties. This is one point given. Next property proposal is compounds are formed when atoms of different elements combine in simple whole number ratios. Yes, compounds are formed when two or more atoms of elements are combining together in different whole number ratios. For example, if you see water formation, how it is formed? Two atoms of hydrogen combine with one oxygen atom to form water. It forms water. Water is a compound. So in that way, compounds are formed when two or more elements combine in fixed ratios. Two or atoms of two or more elements combined in the simple whole number ratios. That is, chemical change is the union or separation of atoms as in whole numbers. So chemical reactions occurs because of this reunion or separation of atoms in simple whole number ratios. For example, if you see here the formation of a compound from two elements nitrogen and oxygen. What's happening here? One atom of nitrogen combining with one atom of oxygen to form a new compound called nitric oxide, NO. 1:1 ratio they are combining here. So it is a union of two different elements. Atoms of two different elements they combine together to form a compound. Okay, compounds are formed by the combination of atoms of two or more different elements in simple whole number ratios. Okay, next, when atoms of different elements combine in different whole numbers ratios, they form different compounds. One more point here extended here, that is atoms of different elements, if they combine in different whole numbers ratios, then they form different compounds. For example, if you say carbon and oxygen, they can form carbon dioxide. We know that carbon dioxide is formed from carbon and oxygen. One more compound is also formed from the same elements, that is carbon monoxide. So carbon dioxide, carbon monoxide, Both are formed from the same elements, carbon and oxygen. But here what happened? They combined in different whole number ratios. In the formation of carbon dioxide, carbon and oxygen they combined in the 1 is to 2 ratio. That means one carbon atom combined with two oxygen atoms. In the formation of carbon monoxide, they combined in 1 is to 1 ratio. That means one atom of carbon combined with one atom of oxygen. So in this way, carbon dioxide, carbon monoxide are formed by same elements. Here, carbon and oxygen combined in 1 is to 2 and 1 is to 1 ratios respectively to give these two different compounds. So, in the earlier point what we have told, elements, atoms of different elements combined in fixed whole number ratios to form a compound. That's one point. Atoms of same elements, they may combine in different whole number ratios to form different compounds. Okay, in the formation of a fixed compound, elements always combine in the fixed ratio. But if elements they combine in different ratios, they form different compounds. Got it? Next point. So those are the postulates given by John Dalton about the atoms, and he tried to explain and try to give reasons for the uh, how these chemical reactions are being valid for all types of chemical reactions, how these chemical laws are being valid. So in that way he has given proposals. But before him, in our India, about 2600 years ago, that means around in 600 BC itself, our Indian sage or rishi called Maharshi Kannada also postulated the same concept on the atoms in his Vaisheshika Sutra. In his literature, Vaisheshika Sutra, he explained about these atoms in the 600 BC itself. That's the greatness of India, of course. The actual name of Maharshi Kannada was Kashyapa. We call him as Kashyapa Mahamuni. He was renamed after his literature called Kana Siddhanta. In this Kana Siddhanta, he proposed about these atoms. He explained there, he proposed that all forms of matter, he called this matter as Padartha because it is Sanskrit literature. He wrote there as every Padartha is made up of small particles called Anus. Anus nothing but molecules. And each Anu may be made up of still smaller particles called Paramanus. So these Paramanus are nothing but we are calling now them as atoms. So atoms, every Padartha is made up of Anus and Anus are composite of Paramanus. So what does that mean? Every matter is made up of small particles called molecules. These molecules are made up of still smaller particles called atoms. So this was a concept given by Maharshi Kannad or Kashyap in his literature Kanasiddhanta in earlier BCs, around 600 BCs itself. Okay. So the word atom which we are using now is derived from the Greek word atomio. Tomio means divisible. Atomio means indivisible. So actually this term atom was first used by Democritus. This was given this name from the Greek word called atomio, that means indivisible. He considered the smallest indivisible particle of every matter as atom, that means indivisible. So what are these atoms and molecules? Very often we may have heard the atoms are the building blocks of all matter. Have you heard this? Yes, this is the point explained in Dalton's theory and in some other theories also. Atoms are the building blocks of every matter. But what does it mean? It means that matter is composed of tiny particles called atoms. Yes, every matter is made up of very tiny particles called atoms. That is why we say atoms are the building blocks of every matter. Because every matter is made up of these atoms. If we take any matter, solid state, solids matter, liquid matter, gaseous matter, whatever the matter you collect, it might be made up of one kind of atoms in it, one or more kinds. If we take example, gold, it is a matter we know, it is solid substance. It is also made up of very tiny particles called gold atoms. The smallest particles of this gold are also called gold atoms. These atoms are all so small that we cannot see them even with a high powered microscope also. Yes, because these atoms are very small, even we cannot see them with very high powered microscopes also. Anyhow, they are not seen with a naked eye, even they cannot be seen with high powered, high sensitive microscopes also we cannot see. Very few microscopes they can show these. The number of atoms present in even in a small amount of matter is very large. If you take a small piece of any matter, that may contain lakhs of atoms in it. Crores of atoms also may be there. That much small these atoms are. For example, if you consider the aluminum foil that we use to pack food, I think you have seen this. Aluminum foils we use often for packing food. If you touch it, you might have seen that it is very thin, isn't it? But it has atoms in lakhs along with its thickness. Even though that is very thin, in its thickness itself, there will be lakhs of atoms. So lakhs of atoms arrangement will be there along with its thickness. That much smaller these atoms are. Hope you understand how the atoms are small. Okay, even that very thin aluminum foil also will be having lakhs of atoms along with its thickness. That much small these atoms are. Okay. We know that substances are made up of atoms or molecules. Yes, every substance is made up of either atoms or molecules. Atoms are the most fundamental of all particles that can have an independent existence. Sometimes two or more atoms combine to form a big particle. When atoms combine, they form molecules. Yes, so atoms are the most fundamental particles of every matter that can exist independently. Actually, for some in some elements, sometimes two or more atoms will be combined to form a big particle which are called as molecules. When the particles of a substance contain only one type of atoms, then that substance is called an element. Okay, in elements, some element they'll be having the single atoms, and in some elements, atoms will be joined together to form bigger particles called molecules. So elements may be containing atoms or molecules, but elements will be having same kind of atoms in them. The substance which is containing only one kind of atoms in it is called an element. Okay, see here some elements are shown. In these elements, atoms are in the combined state. Of course, elements will be having same kind of atoms, but these atoms are in the combined state. If you see the first one, hydrogen element, it contains all hydrogen atoms only. But these atoms are not individual. Two atoms are in the combined state. They form one molecule of this hydrogen. So in each molecule of hydrogen, there are two hydrogen atoms combined one to another. In the same way, in the oxygen element also, there are all oxygen atoms, but there are molecules of oxygen. Two atoms combine together to form one molecule of oxygen. Similarly, in chlorine also, there are molecules of chlorine in which there are two atoms of chlorine. In this way, elements may have individual atoms or the molecules in which atoms are combined, but they'll be having same kinds of atoms all together. Okay. There are many elements whose smallest particle is an atom. Yes, there are so many elements like metals and noble gases. These contain atoms as their smallest particles. Atom metals like iron, copper, zinc, aluminum, silver, gold, these all etc. These all metals they contain atoms as the smallest particles. They do not have molecules. They have atoms as the smallest particles. Not only this, even noble gases also. They also have individual atoms, not combined state molecules. They have individual atoms. So for these elements, atoms are the smallest particles. Okay. Next, some elements are there like oxygen, nitrogen. These are the examples of substances in which the particles are a combination of two identical atoms. Yes, in these elements, the smallest particles are molecules. Molecules means how they are formed. by the combination of two elements. So for oxygen, two atoms are combined to form one molecule of oxygen. Similarly, for nitrogen, the smallest particle is nitrogen molecule, which is formed by the combination of two nitrogen atoms. Okay. Atoms of same element or different elements can join together to form molecules. Yes, atoms of not only always same kind of atoms, same element. Sometimes atoms of different elements also they will combine to form molecules. If atoms of different elements join together to form a molecule or to form a substance, then that formed substance is called compound. Okay, if atoms of same kind they join together, then that is called molecule of element. Sometimes atoms of different elements also they will combine. Then the molecule formed is called molecule of compound. That new substance formed is called compound. For example, if you say water, it is formed from two different kinds of atoms, atoms of hydrogen and atom of oxygen. These all are combined together to form molecule. So in this molecule, as there are two different kinds of atoms, then that is called compound. So water is a compound. Similarly, hydrogen chloride, it is also formed from the atoms of hydrogen and chlorine. Two different kinds of atoms are combined here. So the resultant substance hydrogen chloride is called a compound. Okay. So we can have molecules of elements and molecules of compounds. If molecule is made up of only one kind of atoms, then that is called element molecule. If molecule is made up of two or more different kinds of atoms like this, then that is called molecule of compound. Now we can say a molecule can be defined as the smallest particle of a substance that can have independent existence, and retain all the properties of that substance. So molecule is the smallest particle of any substance that has independent existence and retain the properties of that substance. That is called molecule. If you say for water, the smallest particle is this water molecule, because it is the smallest particle which can represent the properties of water. If you say H, hydrogen is the smallest particle of water, that is wrong, because in water the properties of water are shown by H2O molecule only. Hydrogen itself, it cannot represent the properties of water, because properties of hydrogen are different, properties of water are different. So properties of water, all the properties of water are shown with H2O molecules only. Now we can say that is why molecule is the smallest particle of matter or any substance which represents all the properties of that matter. Okay, that is about molecule. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos. Thank you.